responsible for product and solutions marketing for Aviat Networks, and I'm based here in Silicon Valley in headquarters in California. Before we get started, I want to review a few housekeeping items and let you know how you can participate in today's session, since the audio is, as you probably figured out, is only one way. But during the course of the presentation, you can ask questions using the Q&A widget that you should be able to see at the bottom of your screen. And at the end of the presentation, I will go through any questions that have been submitted and do my best to answer them. So please feel free to enter a question. If you have any issues to do with the sound or anything else to do with the webinar, please also submit a question, and one of my colleagues will help answer your question and help you out. There are other widgets as well at the bottom of the screen. You can read a little bit about me and also some links for contacting the marketing team here at Aviat Networks. We will be recording the webinar as well, so you don't really need to take notes or screen grabs. You'll be able to rewatch the webinar if you like again, and we'll be sending you all an email tomorrow with a link to that recording. So with that, let's get started with the webinar. So as I said, the title of this webinar is The New Trunking, and what it is an all-new solution, a revolutionary new solution that we are introducing to address the market for long-haul microwave trunking systems. This is a market which has been around for several decades in the microwave industry, and Aviat is now taking advantage of the very latest technologies to produce a new, highly integrated, all-outdoor trunking solution, which really drives down the overall cost of implementing high-capacity, long-distance microwave solutions over difficult terrain. And one of the metrics that we use is what we call the cost per megabit. And compared to previous solutions, our new solution, the new trunking solution, reduces the cost per megabit by over 65% compared to other traditional ways of doing trunking microwave. And in addition to that, we're really pushing the capacity of trunking systems, trunking microwave systems in traditional frequency bands all the way up to 10 gigabits per second, which really gives operators a significant choice now as an alternative to deploying long-haul fiber for backbone applications. So looking at trunking microwave architectures, as I said, all indoor trunking microwave has been around for many, many years and has been a large segment of the microwave market globally, probably since the early 90s or even before that with analog microwave systems. All indoor microwave trunking systems are still on the market today. There are new products being released all the time. And they are traditionally very large, requiring a very significant indoor footprint. They consume a lot of power, a lot of DC power, and are generally based on lower modulation and limited channel size capability, which means their overall throughput capability is pretty limited. I'm sorry, I'm just having a bit of trouble here with my there we go. Apologies for the delay. So around about 4 or 5 years ago, Aviat was one of the pioneers in introducing a new alternative for long-haul microwave systems, which we called split mount trunking. This was our STR600 product line, and enabled us to dramatically reduce the indoor footprint required for long-haul microwave systems, and essentially relocated a lot of the components up to onto the tower, and enabled much more efficient use of microwave resources, higher capacities, and overall a lower cost for implementing high-capacity, long-distance microwave systems. And now we're introducing the very latest, what we're calling the new trunking solution. So this pushes the capability of long-haul trunking up to 10 gigabits, dramatically reduces the amount of DC power consumption, and can be deployed in a completely all-outdoor architecture, meaning that there's no indoor footprint required at all. So overall, compared to the traditional all-indoor trunking solutions on the left-hand side of this slide, we're basically achieving 300% more capacity with 70% less power consumption in an all-outdoor footprint. So a significant improvement, and really changes the game when it comes to long-distance microwave solutions. So just a little bit more of a history lesson as far as trunking microwave is concerned. It has been around for many, many years. In fact, the very first long-distance microwave systems were first deployed back in the 1950s. In fact, the first coast-to-coast communications link linking the east coast of the USA with the west coast was implemented in 1952 using long-haul microwave systems. And since then, many millions of kilometers of trunking microwave have been deployed all over the world, many of which are still in operation today. So it's been a very healthy and thriving market. Overall, today it's worth about $300 million worldwide. We see that that market is split evenly between all indoor trunking and split mount trunking solutions. But with the move is much more towards split mount trunking, with that market growing about 25% per year over the last 3 years, mainly because of the tremendous cost benefits that the new split mount trunking solutions delivered over the traditional all indoor. So in the microwave business, we've always been, competing against fiber. Fiber, of course, is the ideal when it comes to long-distance network infrastructure. Fiber can provide unlimited capacity, but the problems with fiber are it can be extremely expensive to deploy. Fiber generally needs to be buried under the ground. Those trenching costs can be extremely expensive. Alternatively, you can string fiber on light poles or some kind of utility pole infrastructure. But then it is also, susceptible to damage or effects of the environment, storms, hurricanes. And in many cases, deploying fiber is just not practical, particularly when you have long bodies of water to cross or mountainous terrain. So fiber can be quite problematic to deploy, but we've seen many of our customers having to consider fiber more strenuously, mainly because of the capacity demands they're seeing in their network. And they're concerned that traditional long-haul microwave trunking solutions just hasn't been able to keep pace with those capacity demands, forcing them to consider deploying more fiber. So microwave is still essential, we feel, particularly for the traditional trunking applications where you're essentially needing to provide communications over very long distances, over difficult terrain, mountainous terrain, or in many cases over very long bodies of water, whether that be lakes or oceans. Here at Aviat, we've deployed successfully long-haul trunking microwave over very long distances, up to 200 kilometers or more. So it can be very effective in providing those very long-distance communications with high capacity and very high reliability and availability. One of the aspects which is critical for long-haul microwave is space diversity. So space diversity is where you essentially install a second antenna at both ends of the link to give yourself a second path so that the radio can cancel out any interference caused by any kind of multipath fading that you experience. And this is very typical, a very typical problem on long links over highly reflective paths like over water, for example. And in fact, probably around about 70% or more of trunking microwave links do require space diversity to enable you to design a very high availability 5 nines or better microwave path. So space diversity is an essential component on most trunking microwave links. And without it, trunking microwave just really, frankly, wouldn't work. So when it comes to microwave, in fact, just about any communications infrastructure solution, total cost of ownership is a really important metric that we try to focus on here at Aviat. So total cost of ownership really addresses or encompasses not just the cost of purchasing a microwave solution, but also addresses all the other aspects, all the other operational aspects of designing, deploying, maintaining, and operating a microwave system over its entire lifetime. And TCO is kind of like an iceberg. The very top small portion which sticks out above the water can be, seen as the purchase price. This is the thing that you most obviously see when you're often making your choices to purchase microwave solutions. But really then there are an enormous amount of hidden costs which can really build up over the lifetime of using microwave, whether that's between 5, 10, or 15 years. And those costs can really increase dramatically depending on your choices. So that includes installation, maintaining the equipment, training and upgrades, spectrum fees, power usage. In particular, for trunking microwave, tower costs are a significant potential cost, both in terms of the cost of the tower to bear the very large antennas which are often needed, but also if you don't own your own towers, then this would encompass also the tower leasing costs to locate your antennas on a third-party tower. And over a 10-year life cycle, those tower leasing costs can be substantial and are directly related to the size of the antennas that you deploy. And then finally, other site costs such as air conditioning and fuel. Many trunking microwave sites are powered by diesel generators. So if you have large shelters requiring costly air conditioning, which needs to be powered using diesel generators, that can significantly drive higher operational costs as well. So what we're really addressing with our new trunking solution is to make a dramatic reduction in all these operational costs that we see below the water level as far as OpEx are concerned. So when it comes to TCO, looking at the traditional all-indoor trunking solutions, they essentially consist of a large 2-meter equipment rack, encompassing the entire microwave trunking terminal. To locate that rack on site, you need a walk-in shelter. This equipment is not particularly robust when it comes to environmental conditions, so it's susceptible to very low temperatures, but also very high temperatures. So generally, this equipment will require temperature-controlled environments, meaning air conditioning. Trunking microwave has traditionally been fairly capacity limited as well, limited to sort of lower modulations, 256 up to 1024 QAM, and channel sizes either 28 or 40 megahertz traditionally, and generally consume a very high amount of DC power. Because these radios are mounted indoors, they're connected to the antennas by elliptical waveguide, and in cases where that waveguide is fairly long, you can have fairly high losses, meaning you need quite a high transmit output power from the top of the rack. Again, that means more power consumption, more heat dissipation, more air conditioning, more fuel consumption, and so on. So as you can see, while trunking microwave has had a long life in terms of the microwave industry, the real pressure to reduce total cost of ownership is really driving down the attractiveness of these solutions. And these are all new trunking microwave solutions that have come onto the market in the last 3 or 4 years. As you can see, they all share the similar characteristic of being very large. So, as I described, all indoor microwave solutions all require a fairly large site infrastructure to support them. And with the pressure on OPEX, we're seeing many of our customers around the world, if not all our customers, really scrutinizing their networks to see how they can drive down their operational costs. And the most obvious way of doing that is to look at the site infrastructure. Large shelters, air conditioning, large generators, and lots of diesel fuel really are no longer sustainable in these days, where operators are fighting against reduced ARPU, tighter budgets, increased demand for capacity with shrinking budgets. Overall, there is a huge focus on getting operational costs down, and this is where we think the new trunking solution offers a significant step forward. I mentioned waveguide before. All indoor radios also need very expensive and complex waveguide subsystems to connect the radio inside the shelter to the antenna up on the tower. This waveguide is notoriously difficult to install. It's very rigid, hard to manipulate, very complex to terminate and secure to the tower. Also, since the waveguide is hollow, it needs to be pressurized and dehydrated to keep moisture out of the waveguide, because any moisture that goes inside will increase the loss of the waveguide and degrade it over time. So expensive dehydrators need to be installed with the waveguide, which also need to be maintained and inspected on a regular basis. So waveguide overall is just a real pain in the neck, and getting rid of it is one of the biggest wins, I think, in moving the radio out of the shelter and up onto the tower. Waveguide has fairly high loss as well. So if your shelter is located a long distance from the tower, or you have a very tall tower and the antennas are located near the top of the tower, the losses on that waveguide can be quite significant. Maybe 10 20 dB, depending on the frequency band. So to offset that loss, to get sufficient availability and capacity over a long-haul trunking microwave link, that means larger antennas to offset the reduction in system gain. Those large antennas, as you can see here, can be huge. So this is probably one of the larger antennas that you'll ever see on a tower. It's 4.6 meters, 15 feet, as you can tell by the guys at the bottom of the photograph. So you can imagine that not only is this antenna extremely expensive to purchase, but getting that up onto the tower is going to be very expensive and difficult. And then locating an antenna like this on a tower dramatically increases the loading on that tower. So in many cases, large antennas means maybe a new tower or strengthening the tower that's already there. And either of those options are extremely expensive. So minimizing the size of the antennas is one of the biggest ways of reducing costs, total cost of ownership when it comes to trunking microwave. So split band trunking enabled us to remove the waveguide, which helped us use smaller antennas. It moved the radios from the shelter up to the tower, just adjacent to the antenna itself. Our STR600 split mount trunking solution that we introduced several years ago was one of the first to do this. It still needed a small indoor footprint, either a 1, 2, or 3 rack unit indoor unit inside the shelter. So still needed some cabinet or shelter support for the indoor unit. And also was or is capacity limited in that it doesn't incorporate the very latest in technologies when it comes to modulation and wide channel support. The other thing about our STR600, which is common with other split mount trunking solutions, is that for space diversity, it's not a very efficient solution because you would need to basically double up the amount of equipment to support a space diversity link, hence driving up the equipment costs and the tower loading. So now with our new trunking solution, we have eliminated the indoor unit completely. So there now is no longer any need for an indoor unit at all. The radios are still located up on the tower, but they are fully self-contained all outdoor radios combined, attached to an outdoor branching unit, which basically multiplexes the RF signals, the 4 RF channels, onto a single antenna polarization. The other big win for our new trunking solution is an integrated space diversity capability. So now no longer do you have to add a second radio for the space diversity support. The space diversity receiver is built in to this solution. So no additional equipment required to implement a space diversity link. So much more cost effective, much lighter weight, lower power consumption, lower cost per megabit, and lowest overall total cost of ownership when it comes to trunking microwave. So the building block for our new trunking solution is called WTM4500. So this is the latest variant in our new WTM4000 all-outdoor microwave solution that we introduced last year in 2017. So WTM4000 is a dual transceiver radio, a 0 footprint. So it incorporates 2 transceivers to support dual channel operation in a fully integrated all-outdoor design. So WTM4500 essentially turns the dual transceivers into a single channel space diversity receiver all outdoor radio, all in a single highly integrated and compact package. And this is what it looks like in this slide here. So it's basically just a single all-outdoor radio. It has 2 waveguide ports, so you can connect it to both the main and the space diversity antenna. And there's no other equipment required to implement a full space diversity terminal. No indoor unit, no second RF unit, just the single WTM4500. The operational bands are from 6 to 11 gigahertz today, with a single radio channel operating at 4096 QAM and up to 112 megahertz channels. We can support up to approximately 1.2, 1.25 gigabits of throughput in a single radio channel. So very, very high capacity in a very compact package. And because it's common with our already released WTM4000, out of the gate, the WTM4500 supports all the platform features supported today by the 4000. So today it supports full advanced Layer 2 carrier Ethernet. It's fully upgradable to Layer 3 IP/MPLS with a software upgrade in the future. It's fully purpose-built for software-defined networking, so it incorporates netconf and YANG natively in the radio, being the only microwave radio on the market today to do so. It incorporates built-in 4 traffic interfaces at the bottom of the radio, including 2 GigEs, 1 with optional PoE, and 2 10 GigE ports. And it has options for payload encryption and management security as well. So from a capacity point of view, traditional trunking solutions have typically supported around about 400 megabits of throughput using up to 1024 QAM and a 56 megahertz channel. So with WTM4500, we're boosting the modulation up to 4K QAM, which gives us more than 20% throughput improvement. We can also implement header compression techniques to enable higher throughputs for smaller frame sizes, typically up to 20 or 30% more throughput for an average frame size mix on the payload capacity, getting you up to nearly 700 megabits of throughput. And then we can double the channel bandwidth from 56 up to 112 megahertz in a single transceiver to give you up to 1.25 gigabits of throughput in a single radio. So the highest capacity available today in a single transceiver design for trunking applications. So this table shows some of the other capacities that are possible with the WTM4500 for other channel spacings. So I mentioned the 112 megahertz with the throughput acceleration can get up to typically around 1.2 gigabits of throughput. As you can see, for a typical 28 megahertz channel, that figure can be up to 300 to 600 megabits of throughput, depending on the frame size. So this is the architecture of the WTM4500 space diversity terminal. So as you can see, inside the radio, it's fully integrated with the modem, a 60 gigabit Ethernet switch, carrier Ethernet switch, 2 transceivers, one of which only has the receiver enabled for the space diversity reception, and then diplexers are fully integrated inside the box. So then there's nothing else that's required to connect this radio to the antennas other than flex waveguide or coax cable to connect it to the main and the diversity antennas. So very compact, 0 footprint, all outdoor, very high capacity space diversity terminal, lowest cost per megabit. Then what we do to get the very high capacity all outdoor trunking capability is that we take the WTM4500 and we can attach 4 of them to what we call an outdoor branching unit. So this outdoor branching unit contains all the filters and the circulators required to combine those 4 radio channels onto a single antenna polarization, both for non-diversity and space diversity applications. So here you've got 4 radios. Each radio can operate up to 1.2, 1.25 gigabits of throughput to give you up to 5 gigabits of throughput for a 4+0 system. Then we can use 2 of these configurations, 2 of the OBUs with 8 WTM4500s to give you up to a full 10 gigabits of throughput on a single antenna. One of the other applications which the new WTM4500 opens up in the trunking applications is the prospect of what we're calling urban trunking. So typically trunking solutions have been for long-haul backbone applications in sort of remote areas, over water, across deserts, over mountain ranges. But now the WTM4500 in its OBU configuration gives you the capability of implementing long-haul, high-capacity links in urban and suburban environments. Being all outdoor in a relatively compact configuration enables you to locate the radio on a rooftop, where before with an all-indoor trunking solution, for example, you just wouldn't have had the capability of deploying something like that in that kind of application. So we do see increasing applications for what we call urban trunking for the all-outdoor trunking application. So now, as I said, with what we call the STR4500, with the 4 4500s and the OBU together, with 4+0 configuration, you can get up to 5 gigabits of throughput and up to 10 gigabits of throughput with an 8+0 configuration, all on a single dual-pole antenna or in a space diversity configuration with 2 dual-pole antennas. So again, this shows you the architecture arrangement of the STR4500 with the 4 WTM4500s all attached to the outdoor branching unit, or OBU. And then you can connect your main antenna and your space diversity antenna directly to the OBU for the fully implemented all-outdoor trunking solution. So one question we get from customers is, wow, all this stuff up on the tower, that must be pretty heavy. You know, and some concern expressed about the additional tower loading involved with locating the 4 WTM4500s and the OBU up on the tower. So what I'm showing here on this tower is comparing the STR4500 weight, dimensions, and wind loading compared to typical specifications for antennas in trunking applications. So with trunking systems, obviously in most cases you're looking to implement longer links. So in general we expect the antennas to be at least 1.8 meters all the way up to 2.4, often 3.0, and in some very rare cases even larger, up to 4.6. And as you can see, the weight of the STR4500 compared to these larger antennas is merely a fraction. So looking at, say, a 3-meter antenna, the weight of that antenna is 250 kilograms on the tower, you know, over 5 times the weight of the STR4500. The dimensions, when it comes to wind loading, Of course, for a 3-meter antenna, you've got nearly 8 square meters of area facing the wind, compared to less than half a meter squared for the STR4500. And that equates to a wind loading of nearly 2,000 kilograms for a 3-meter antenna, compared to less than 50 kilograms of wind loading for the STR4500 for a typical maximum wind speed of 200 kilometers per hour. So as you can see, even though the equipment has a relatively high weight compared to the weight and the wind loading of the typical antennas that you're putting on a tower, particularly if you're using space diversity, you can double the weight and the wind loading here by adding the second antenna. The weight of the STR4500 is really negligible compared to the antenna loading. And when we look at the overall TCO reduction of the STR4500, you're reducing potentially the antenna size by one to two sizes by eliminating the requirement for waveguide. So now there's no waveguide related losses. The transmit power output from the STR4500 is more than 30 dBm directly into the antenna. So you have significant system gain, enabling you to minimize the size of the antennas. So that saves on wind loading, tower loading, less strengthening of the tower is needed. You're reducing the size of the antenna, so tower leasing costs are lower, the cost of the antennas are lower, and so on. Installation costs are dramatically lowered by the size of the antenna, but also by eliminating waveguide. On the indoor side, you're reducing a traditional all-indoor trunking radio from a 2-meter rack down to a very minimal indoor unit or no indoor unit at all, and a significant reduction in power consumption, so between 60 and 70% reduction in power consumption. So overall, about 65% lower cost per megabit for the new trunking solution from Aviat. And this is another graph just that shows you graphically the size of the circles, the cost of the solution, and on the vertical axis you have the number of radios, the number of transceivers required to implement the capacity on the horizontal axis. So you can see the WTM6000 or an indoor trunking type solution requires 16 transceivers to give you 3.6 gigabits of throughput with a very high equipment cost. Comparatively, the STR600, you need 8 transceivers to implement 3.2 gigabits of throughput with a lower cost than the all-indoor trunking, but still fairly significant. And then when we look at the new trunking solution, the STR4500, we see that we can support significantly more capacity with a fraction of the number of transceivers at a significantly lower equipment cost. So overall, coming back to this slide, just to accentuate the benefits of the new trunking solution from Aviat. So now we've significantly increased the capacity of trunking solutions by more than 300%, increasing capacity from around 3 gigabits all the way up to 10 gigabits efficiently and very cost effectively, with the ability to deploy an all-outdoor trunking solution without the requirement for an indoor unit at all. Significantly lower TCO, reduced power consumption, smaller antennas, and overall lower cost per megabit. So that brings me to the end of the presentation. So now I have a few minutes to be able to answer some of your questions, and we have a number of questions that have been submitted, so I will try and take a few of these in turn. So I have one question: what is the maximum transmit power? So the WTM4500, depending on the frequency bands and the modulation and the channel bandwidth, can deliver up to 32 dBm of transmit output power. The OBU has a certain amount of losses to multiplex the multiple radios onto the antenna, but overall, compared to an all-indoor trunking solution, the overall system gain, taking the transmit power, the receive threshold, and the antenna coupling losses together, overall, the STR4500 has much better system performance than the previous alternatives. Let me see. So I have a question about the 11 gigahertz channel arrangements. And how many 80 megahertz channels would we need to license to achieve the maximum bandwidth of using 2 OBUs with 8 ODUs? So with 8 WTM4500s and 2 OBUs, you would be able to support 8 80 megahertz channels in the new trunking solution. I hope that answers the question. I have another question: with a 2.4 meter antenna in the 6 gigahertz band and 4K QAM, what distance can be achieved? So there's not an easy answer to that. With the very high modulation running at 4K QAM, we would generally, we would certainly recommend the use of adaptive modulation. So typically, you would design the radio path for 5 nines at a lower modulation, say 512 QAM or 1024 QAM. That would give you the best distance performance traded off against the actual capacity. So the actual availability at 4K QAM would be something less than 5 nines. But with the distance that can be achieved, again, will depend on the path. But we would expect path lengths of, I would say, a minimum of 50 kilometers or more, maybe up to 70 or 80 kilometers, depending on the terrain and the nature of the path. So with trunking radio systems, if you have both ends of the radio path at very different height elevations, that can be very helpful in achieving better performance for the radio path. Again, if you're going over mountains as opposed to a large body of water, you can maybe achieve longer distances as well. So there's a number of factors, but as I said, we have successfully implemented extremely long trunking radio paths, in excess of 100 kilometers and all the way up to 200 kilometers all around the world. I have a question about MIMO and whether the WTM4500 uses line-of-sight MIMO. So this solution, the new trunking solution that I've just described, does not employ MIMO. So MIMO is an option where you use 2 radios and 2 antennas to get 4 times frequency reuse of the same channel allocation to get much higher link capacity. So this solution does not employ MIMO. It's not possible to deploy MIMO and space diversity simultaneously. So this is a non-MIMO solution in terms of 4x4 MIMO. We can implement these trunking solutions with XPIC. So we do have frequency reuse capability using XPIC. So we can do 8 channels, 10 gigabits with 4 frequency allocations using both polarizations, vertical and horizontal. I have a question how the link aggregation is done in the 8+0 configuration. So that's a good question. In the 8+0 configuration, we can do the aggregation of the traffic from those 8 radios in a variety of different ways. We can do some of the aggregation up on the tower by interconnecting the WTM4500s and implementing layer 1 link aggregation up on the tower. Or we can do that link aggregation, that traffic aggregation, with an indoor unit indoors. So we can run the cables, the fiber cables, down from the WTM4500 to an indoor switch or router. That could be our Aviat CTR8540. We could do the link aggregation using that unit. Or we could implement it using any third-party switch or router that you may have already existing on site. So really, that would come down to the overall network design. So this is where Aviat would work closely with you to determine the best solution for your specific network application and existing deployed network infrastructure. So I have another question. Is the space diversity switched or phase combined in IF? So it is a switched space diversity as opposed to IF combining. Typically, Aviat has implemented baseband switching space diversity combination. So essentially, we're switching essentially on a frame-by-frame basis, looking for the best quality signal very, very rapidly, and we achieve equivalent space diversity improvement performance compared to a traditional IF combining approach. I have another question for the space diversity antenna connection. Is the default to use a coax cable or a waveguide flange interface is optional? So the standard connection method from the OBU or the WTM4500 to the space diversity antenna is via coax. And the reason for that is not only for simplicity, but also to minimize the waveguide losses between the radio and the antenna. Another question, does the data interface support fiber? So the answer is yes. We have the option to support either a optical fiber connection to the WTM4500, either with a 1 GE or a 10 GE or a 2.5 GE optical fiber interface, or we have also 2 electrical 1 GE interfaces as well on the WTM. Another question on the power consumption of the WTM4500. So it's typically around, depending on the frequency band, and the power level that the radio has been run at. The power consumption is up to around 80 watts per unit. So with the STR4500 with the 4 radios, the power consumption is around 320 watts, typical for that configuration. I have another question. Does the solution support 120 megahertz channel bandwidth as well? So the answer to that is no. Right now, the maximum channel bandwidth we support on the WTM4500 is 112 megahertz. We are looking at improving or increasing the channel bandwidth support in the future, and it is something that we're considering adding to our roadmap. But today, we're not supporting that. So I have another question on availability. So the WTM4500 in the single ODU space diversity terminal configuration is available today for order. We have shipped radios, WTM4500s, to customers already, and they are now already have been deployed and are in operation. The STR4500 configuration with the OBU is not yet available, so this will be generally available in the second half of this calendar year. So we will be able to quote that product very, very soon. So please contact your local Aviat representative for more information on that product. I have a question on Ethernet packet synchronization. So the WTM4500 supports the same packet synchronization schemes as we support on the WTM4000 platform, which includes synchronous Ethernet and also 1588 V2 phase synchronization, transparent clock, and we will also be introducing a boundary clock capability as well later this year as a part of our roadmap for WTM4000. Let's see, sorry, I'm just trying to select another. So I've had a couple of questions about whether you can configure 2 STR4500s as a repeater. So the answer is yes. We don't support a repeater in a single box or a single OBU. So essentially, we would configure that as back-to-back terminals. So you would have one STR4500 pointing east and another STR4500 pointing west. A question whether WTM4500 can support E1 connectivity. So the answer is yes, it can, but you would need to use it in conjunction with our CTR8540 indoor unit. There is no E1 interface available on the WTM4500 itself. So what we would do is connect it to the CTR8540. You can connect it by fiber or via the PoE plugin on the CTR8540, and then we have up to 16 E1 pseudowire ports on the 8540 that you can then use. I have a question about 4.4 to 5 gigahertz frequency support. So today, the WTM4500 supports frequency bands from 6 to 11 gigahertz. We don't currently have a commercially available 4 or 5 gigahertz product available, but it is something that we are looking at as a potential addition as a part of our roadmap for this solution. So again, please contact your Aviat rep to find out more about that. So I think I've answered pretty much all the questions that I can. So that leads me to thank you very much for attending this webinar. I'd like to remind you that we'll be sending out an email with a link to the replay of the webinar, so you can watch it again at your leisure, or you can please forward it to your colleagues who may not have been able to attend this webinar. If you would like a copy of the presentation, please contact Aviat Marketing using the contact widget at the bottom of your screen, and we can email the presentation to you. So thank you very much. I hope you found this webinar rewarding, and thank you for attending. Goodbye.